Hi everyone, welcome to JavaTechie. So I believe you all heard a word called virtual thread. If not, don't worry, I am here to tell you. Virtual thread is a new feature introduced in JDK 19 as a preview feature which will help us to improve an application availability, throughput and code quality on top of reducing memory consumption. The concept of virtual thread has gained considerable attention in recent times and many programming languages are updating their thread library to support the virtual threading feature. So in this tutorial, I will provide a deep introduction to the virtual thread with internal and also will understand how virtual thread is different from our current thread architecture. Okay, so without any further delay, let's get started. So before Java 19, there are two types of thread, operating system thread, or you can also call it as a kernel thread, and the other one is the platform thread. So these operating system thread are managed and scheduled by the operating system itself. However, the platform thread cannot be directly executed. It must be mapped to a operating system thread. So in the end, operating system thread is the one which execute every instruction in the computer system. So when we usually create a thread, it creates a platform thread and then it make one-to-one mapping with an operating system thread to perform any task. If you observe, this current thread working principle is fine, right? There is a one-to-one mapping between a platform thread and operating system thread and we are able to execute concurrent tasks. Then what's wrong with it? Why Java developer introduced another thread called virtual thread? Don't worry, I will explain everything. Before you know why we need virtual thread or what is the advantages of using virtual thread, let's understand thread per request architecture so that it will easy for me to differentiate virtual thread and platform thread. Okay, now let's assume my application hosted to one of the application server like Tomcat or JBoss, and each server will have their default thread pool so that bulk request can concurrently handled by individual thread. Now here all the threads wait in the pool for a new request to come. So once the new request comes, the thread picks up the request and it makes application call to serve that particular request. Okay. Once request sent to the backend application, then thread needs to wait until he received response back from the backend. Once the response comes back, again the thread will return back to the thread pool. This is the typical thread per life cycle model or thread per life cycle architecture. So if you observe carefully, thread is only used while process the request and rest of the time it is basically waiting or doing nothing, which is not good, right? Now if you will relate this architecture from thread perspective, whenever a platform thread is created, an operating system thread is allocated to it. Only when the platform thread exits the JVM, this operating system thread is free to do other tasks. Until then, it cannot do any other task. According to this thread per request model, the operating system thread will be unnecessarily locked down while he is not doing anything. Since operating system thread are precious and finite resources, its time is extensively wasted in this platform thread architecture. Now if you look into JVM memory management, we have various segments to manage different type of instance. We have method area where all the static and class related metadata is assigned in that particular area, and we have heap area where it allocate memory to the object or to the instance. Next to that there is something called Java stack area. Okay, this is the place where thread allocate its memory. If memory is already allocated to the thread and if he is not doing anything or simply sitting idle, then it's waste of memory, right? So if you observe in this platform thread architecture, we are having lot of challenges to increase the throughput of our application. Now how we can overcome it, or what is the best way to deal with multi-threaded environment to achieve the proper CPU utilization? That is where this virtual thread have been introduced in JDK 19 in order to efficiently use underlying operating system threads rather than blocking them. So let's understand the same thread per request model with virtual thread architecture. Then you will understand how this virtual thread feature is so powerful and it's recommended to use in enterprise application. Okay. Now the scenario is same. We have an application hosted to the web server and that particular server is having their own thread pool with couple of thread. But in virtual thread the structure is bit different, or you can say the memory management is bit different. I will compare the memory management in virtual thread and platform thread. In virtual thread architecture, all the virtual thread will be residing in Java heap memory like a normal object. So when request comes to the application server, then it won't directly picked up by the platform thread present in the thread pool. Rather, it will picked up by a virtual thread. Then virtual thread will be assigning to a platform thread, and then platform thread will again assign to the operating system thread. Now the request will be handled by the virtual thread only when it processes the request. Otherwise, virtual thread will be residing just as an object in the Java heap memory. Okay. Now you might have a question: if virtual thread is going back to heap memory, then what will happen to the platform thread and operating system thread? That's the key factor here. If there is no real work executing, then all the thread will detach from each other. That is what the out of the box feature given in virtual thread. Now keep a note, virtual thread are mapped to the platform thread when it does the real work. Unnecessarily, virtual thread will not going to assign to any platform thread. Operating system threads are not allocated to the platform threads until real work needs to be executed. If there is some work must need to be executed, then only platform thread will assign to the operating system thread. So these two are the key concept of virtual thread. Okay, that is the reason this virtual thread is lightweight and it is easy to use in multi-threaded environment. You can spin up 10 million of virtual thread, but you cannot spin up the 10 million platform thread. That is how it is lightweight. So again, just have a quick recap. If any request comes, virtual thread will be assigned to the platform thread, which turns use operating system thread for execution. That's pretty clear. So you understand platform thread and virtual thread architecture with internal, right? So let's deep dive one step ahead to do high level benchmarking of CPU utilization in both the case. I mean platform thread and virtual thread. So I will explain in the platform thread, then you will understand what is the disadvantages, then why do we need the virtual thread. Okay. So to perform high level benchmarking, consider a web server deployed on a machine with 16 GB of RAM, and each thread needs 20 MB of RAM. It means we have 16 GB RAM capacity and each thread needs 20 MB. Then how many threads with this 16 GB my system can accommodate? 16 into 1000 by 20, which is 800 thread. By using this 16 GB RAM, I can spin up 800 thread on my system. Now let's assume to process a single request, my system took 100 millisecond. 0.1 millisecond for the request preparation, 0.1 millisecond for response processing, and the entire time it took 100 millisecond to complete or to process one single request. Now let's assume I have received 800 concurrent requests. Now I have 800 thread and 800 requests. So it means one thread can handle one request, right? It seems the thread count reached its maximum capacity because we already spin up all the possible thread, that is 800, and total number of requests 800. So each thread can handle one request. That is how we just trying to analyze. Okay. Now let's calculate the total CPU time for a single request. So to calculate the total CPU time for a single request, request preparation took 0.1 millisecond and response processing took 0.1 millisecond. So the total will be 0.2 millisecond for a single request. Now we have 800 requests, right? For 800 requests, it will take 800 into 0.2 millisecond, which will be 160 millisecond. Next, just evaluate the CPU utilization per 1 second. Okay. Now, to evaluate the CPU utilization, total CPU time for a single request is 0.2 millisecond, and for 800 requests it is 160 millisecond, right? So 160 and 1000 millisecond, which is just a second, which is 16% now. Okay. Now if you look into this number, in a second only 16% of CPU was utilized. This shows that we are underutilizing the CPU. We are not optimally utilizing the CPU at its capacity. Now, if you observe carefully, 16% of CPU is being utilized if you are running 800 thread. Now, how many thread I need to utilize the CPU 90%? How to calculate? The logic is simple, right? So, number of thread required is 4500. But I have 16 GB RAM. With 16 GB RAM, I can only trigger 800 threads. This shows that our backend server can actually capable of handling 4500 requests per second by utilizing 90% of the CPU. Due to the constraint, we are able to create only 800 thread. Now, if I want to spin up 4500 threads, then I need to increase my RAM capacity. How much RAM is required to create 4500 threads? So considering each thread required 20 MB of RAM, 4500 into 20, 90 GB. So we need 90 GB of RAM to trigger 4500 threads to achieve 90% of CPU utilization. This number is crazy, isn't it? Hence, with platform thread, we are not able to utilize the hardware at its full capacity. But you can overcome this if you are using virtual thread. Now, as you understand, each thread need 20 MB to process. But if you are using virtual thread, it will take very light memory in some bytes. Okay, even it won't look into the MB. So you can spin up million of thread with limited RAM capacity, and you can improve your CPU utilization as well. Okay, fine. I believe we are good with the theoretical understanding. Now let's get our hands dirty with virtual thread code, and whatever the theory we have discussed so far, we'll try to prove few of them in the code itself. Okay, and also in my upcoming session, we'll do the proper benchmarking using JMeter, or we'll just visualize the memory management using the any third party tool like JProfiler or JVisual BM. I'll come with the different tutorial to do the proper benchmarking. Also in coming tutorial, we'll integrate it with our Spring Boot app. Okay, but for now, I'll just give you some heads up about how you can create the virtual thread and whether it really depends on any platform thread or not to process it, and how much time usually takes to spin up a thread. I mean, few of the statistics I will show you with the virtual thread code. Also, you will understand how you can create the virtual thread. Okay, let's move into the IntelliJ IDEA. Then make sure that you have installed JDK 19 or higher version of it. So if you observe, I already installed JDK 20 for my machine. If I will show you that, see here I have JDK 20 with me. Okay, make sure to use JDK 19. Since this is the preview feature, I will show you how you can mark it as a preview. And one more note, make sure you should use the latest IntelliJ version. If you are using any version of 2021, then I don't think it will work, because I tried with my old IntelliJ IDEA. It support up to JDK 17. I didn't find any option for JDK 19. So keep a note, try with the latest IntelliJ IDEA version. Okay. Now let me quickly create a class to demonstrate this virtual thread. Virtual thread demo. But before I write anything in this class, make sure you need to mark this feature as a preview either in your pom.xml like this, add this particular plugin, specify the target JDK 20 or what version of JDK you are using, and make sure to specify the argument double dash enable dash preview. Okay, you can add it in the pom.xml or you can add it in the edit configuration, that is up to you, but I have added in the plugin. Now let me minimize this, define the main method. Then I will show you how you can create the virtual thread and platform thread using this JDK 19. Okay, so thread is a class and there is a factory method of virtual. Can you see here? Of virtual, and also you will find of platform. Okay, so first let's create the platform thread, and then you want to start this thread now or you want to unstart it later when you need, you want to start and join. For now I want to start it. Okay, and if you observe, the argument of start is runnable. So I can pass the lambda and I can print something, platform thread and the thread name. Fine. Now I will just add a line here. Now to create virtual thread, you can use same thread dot of virtual. Okay, again you have option, either start it now or do it later, and also pass the runnable. In both the case, the start method and onStart method argument is same, which is runnable, because runnable is the way to create the thread, and whether you want to make it platform or virtual, that is up to you, or it depends on the method signature what you have written here. So also I just want to print this. Fine. Now let me run this. If you observe the output here, this is what the platform thread. Okay, thread name is main, and if you see the virtual thread what we are printing here, name of the virtual thread, which is virtual thread 21, and if you check the next literal, fork join pull dash 1 dash worker dash 1, this is nothing your platform thread. Okay, this literal pointing to your platform thread from the fork join. So what it means, this virtual thread is running on top of this particular platform thread. Okay, this is what we discussed, right? So if you observe here, the virtual thread will run on top of platform thread, then again platform thread will run on top of OS thread. So virtual thread we found the literal, and platform thread it will get from the fork join. This is what the literal. Okay, now next let's try to understand. We'll create a couple of thread, let's say 10 thread, then we'll try to understand whether the virtual thread, if there is no work, whether it will be available or it will go and stay in the Java heap memory, or it will target to the different platform thread. Okay, this is what the theory you understand, right? Now we'll understand it in code. So let me add few line of code, I mean simple Java 8 stream. Okay, let me comment this for now. So if you observe here, this is very simple statement. In stream of range 0 to 10, I want to create 10 thread, and then I'm just doing map to object, and inside that map to object I'm creating the virtual thread, but I'm not starting it now. So what I'm doing, on this unstarted, I'm giving this runnable task, and what I'm doing in this task, nothing, simple statement. I'm just printing the 0 thread, okay, and its name. Then I am going to sleep for 10 seconds. Then after 10 seconds I just want to verify whether the virtual thread what I am creating is pointing to the same platform thread or it is depending on other platform thread. Okay, then I'm just converting to list, since I am creating the 10 thread object, and I am iterating them and starting each thread, and again I am iterating and joining each thread. Very simple statement. Okay, to just save our time I just copy paste the code, but you can give a try, there is nothing wrong. So this index I will change it to the something like uh, th count, thread count. Okay, now let me run this piece of code. So if you'll see the output here, very interesting, just try to understand this literal. Okay, so virtual thread 20, initially it started executing, then we have applied, if you observe here, let me move it down. If you observe here, we just add the thread sleep for 10 seconds. Intentionally we are blocking the thread. Okay, so initially virtual thread started on top of platform thread fork join pull 1 worker 1, then it went for 10 second block, then immediately virtual thread release the lock, or it got released the platform thread fork join pull 1 worker 1, and again it took the help of this particular platform thread fork join pull 1 worker 2. Okay, so first it begin with this platform thread, then when this virtual thread went to the block, it went to the Java heap memory. When it come back, it again assigned to the different platform thread, not the same one. Can you see here, this is worker 1 and worker 2, both are different platform thread. So clearly we can see that whenever the virtual thread is blocked, it releases the platform thread and its stack is moved to the heap memory. Now the platform thread can be pinned to another virtual thread to carry out its task. Okay, when the blocking operation is finished, the virtual thread will be pinned to any free platform thread and will mount its stack on that particular platform thread. That is what it's doing here. Fine. The virtual thread is the same because the first thread I am printing here. So the thread is same, but it is trying to use the different platform thread when it is going to the block. Okay, this is the next statement we have understand here, right? It release the, or each of the thread will be detached from each other. That is what we understand, right? When there is a blocking. So this is clear. Now the next step, what I want to show here, we want to spin off thousand of virtual thread and platform thread, and we'll see how much time each thread is taking to execute, or whether the virtual thread is going to be fast or platform thread is going to fast. That is a simple demo. Okay, so I will modify in the same code. First I will define system current time millisecond, then I'll just define bar, let's say for now 1000. Okay, I'll just define here. Fine. Then I don't want to write anything, any code, because I just want to uh, print out the time taking for each thread execution. I mean, to spin up 1000 virtual thread, how much time it is taking, and to spin 1000 platform thread, how much time it is taking. Okay, this is the simple thing I am going to demonstrate. So what I'll do, I'll again find the end time system dot current time millisecond. Then I'll just print millisecond used to launch thread count or total thread end minus start. Okay, simple code, right? Fine. Let me zoom this. Yeah. Now, if I'll run this piece of code, did I comment? Okay, I modified it, right? So now if I'll run this piece of code, I am trying to create 1000 virtual thread. Okay, we'll see. Let me run this class. For 1000 virtual thread, it took 97 millisecond. Okay, let me add another 0, 10,000. For 10,000, it took 184 millisecond. For 1 lakh, let's see, it is taking 511 millisecond. Okay, I mean, to create 1 lakh thread, it is taking very minimum time. But let's try same using the platform thread. Okay, of platform to trigger 1000 thread, sorry, 1 lakh thread. Let's see how much time it is taking. Can you see the output here? To trigger or to initiate 1 lakh thread, it took 11,809 millisecond. See the difference. In case of virtual thread, it is only taking 511 millisecond. But in case of platform thread, it is taking 11,809 millisecond, which is near to the 11 second, right? Now if I'll reduce 10 for 10,000, let's see how much time it is taking. It is taking 1994 millisecond. But this, if I'll make it virtual thread, it will take very minimum time because the virtual thread is lightweight. That is the reason it was able to spin up quickly. Okay, so this is another difference what we understand in the theory, that it is very expensive to manage or to maintain platform thread, but virtual thread is lightweight, and you can see the proof here, right? So really this Java 19 virtual thread feature is simply awesome, and thanks to the project Loom guys, they are doing the great job by introducing this kind of virtual thread feature to achieve better concurrency and to improve the throughput with the lightweight thread. Okay. Also in my upcoming session, I will do a couple of more video on virtual thread. Once I will get more familiar with the internal of virtual thread, once we'll do the benchmarking of virtual thread. Okay. Do let me know in a comment section if you guys have any doubts. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.